This video is going to walk you through everything that we do on Monday, September 27th. We're covering Unit 1, Lesson 7 today. So to follow along with today's lesson, you're going to want to get yourself to the Monday 927 folder. You've probably already found the video here in the asynchronous makeup work folder. In the main Monday folder, you will want to open two things. The first thing you want to open is Unit 1, Lesson 7 classwork. I'm going to go ahead and open that in a new tab. Now, if you can't open that in a new tab, you can open up Unit 1, Lesson 7 classwork, and then come back to the Monday 927 folder in a second tab so that you make sure you end up with two tabs open. This tab, Class Kick, Unit 1, Lesson 7 classwork, and this tab, which is Activity 2 image. We don't need this quite yet, but we're going to get to it in the second activity, and you're going to want to have this picture open. So, go ahead and type your name into the Classic assignment, and you'll be able to see our first activity. Remember that with Classic, you can zoom in and zoom out using these buttons here if you want to look at all the pictures at once. You can also open Classic in a new tab if you would prefer to see it outside of Schoology, which can sometimes feel easier because it ends up looking bigger. So 7.1 says, here are some drawings of a school bus, a quarter, and the subway lines around Boston, Massachusetts. The first three drawings are scale drawings of these objects. So we have a scale drawing of an actual school bus, we have a scale drawing of a quarter, and we have a scale drawing of a map of the subway lines around Boston. Then we have three other drawings, and it says the next three drawings are not scale drawings of these objects. So, the directions say to discuss with your partner what a scale drawing is, but since you missed class today, I'm just going to have you type at least 3 bullet points, so you can use this text box to type. A scale drawing is, and tell me some things that you notice about a scale drawing. Go ahead and pause this video to answer activity 7.1. So please pause this video to answer activity 7.1 and come back when you're finished. So some things that you might have noticed about the scale drawings, a lot like scale copies, is that they look proportional. In the first picture, the school bus looks how a school bus would actually look. And in the second drawing, the school bus is curved in places where the school bus isn't curved. We also notice that scale drawings have the detail that the actual copy has. So you can see that in the scale drawing of the quarter, you have the actual head that's on a quarter, the actual lettering, etc. And those are just a few features of scale drawings to notice, but we're going to talk more about them throughout today's classwork. So, activity 7.2, sizing up a basketball court, says, your teacher will give you a scale drawing of a basketball court. The drawing does not have any measurements labeled, but it says that 1 centimeter represents 2 meters. Measure the distances on the scale drawing that are labeled A to D to the nearest tenth of a centimeter, and record your results in the first row of the table. So, notice that in this other tab that we opened, we've got a drawing of a basketball court. And your job is to measure the distance in the scale drawing and the actual court. Now, I understand that working from home, you might not have the measurement tools that you need in order to measure the scale copy. So, in the first row of the table, I'm going to tell you exactly what those different distances measure. As you follow along with the video, you should then be able to add to your table exactly what I'm adding. So notice that the way that we're getting these measurements and the way that we know what to measure is what's listed in the top row of that table. So for example, we see length of the court. Well, the length of the court is A right here. It's how long the court is. If you had a ruler with you, you would measure A at 14 centimeters. And you can just go ahead and type in your table what I type in mine. B is the width of the court, so it's how wide the basketball court is. The width of the basketball court is 7.5 centimeters. Then our next measurement is hoop to hoop. That's from here to here. And our measurement from hoop to hoop is going to be 12.4 centimeters. And finally, the 3-point to the sideline, which will be D right here, this small piece, is going to be just about a half of a centimeter or 0.5 cm. Now, this is the only part of the activity that you needed some help doing from home. Other than that, you'll be able to finish the rest of the questions. So question 2 says, the statement 1 centimeter represents 2 meters is the scale of the drawing. It can also be expressed as 1 centimeter to 2 meters or 1 centimeter for every 2 meters. What do you think the scale tells us? Go ahead and pause this video and answer question 2, and then we'll talk about what information we get from the scale. Okay, so at this point in the video, you should have paused and answered question 2. Let's talk about it. When we see a statement like 1 centimeter represents 2 meters, what that's telling us is 1 centimeter in the drawing equals 2 meters in real life. So, for example, if you see a part of the picture that's 1 centimeter long, you know that if you were looking at the basketball court in real life, if it was right in front of you, that part of the basketball court, it wouldn't be 1 centimeter long, it would be 2 meters long. So we can use that scale to help us fill in the table in question 3. How long would each measurement from the first question be on an actual basketball court? Explain or show your reasoning. Well, I know that every 1 centimeter, and again, this is right here, every 1 centimeter represents 2 meters. That means that if I have 14 centimeters, each one of those centimeters is going to represent 2 meters, which means if I multiply 14 centimeters times 2, I know that 14 centimeters represents 28 meters, which means the length of the actual court is 28 meters. In other words, this picture here, where A was 28 centimeters, is actually representing, or it was 14 centimeters, was actually representing 28 meters because each of those centimeters represents 2 meters. Now, I want you to go ahead and pause this video to fill in the rest of the table. Remember that the same rules apply. 2 centimeters, or 1 centimeter is 2 meters. 1 centimeter is 2 meters. Okay, so let's talk through question 3. You should have given it a try on your own. Here's another example. I know that the width of the court is 7.5 centimeters. Every one of those centimeters represents 2 meters. So I can multiply my width times 2, which gives me a total distance of 15 meters. And I can do the same exact thing for hoop to hoop. I know that the distance from the hoop, so here from a hoop to a hoop, is 12.14 centimeters. Each one of those centimeters represents 2 meters. 12.4 centimeters times 2 is 14 or 24.8 meters. And again, I'm just going to go ahead and add that to my table. And then in D, we know that we've got half of a centimeter. If 1 whole centimeter represents 2 meters, that means that half of a centimeter is going to represent 1 meter. So my final table entry is going to be 0.5 times 2, because again, each centimeter represents 2 meters, which gives me a total of 1 meter. Now, notice how all we needed to do to fill in the table was to use the original relationship that we had between centimeters and meters. We can use that same exact strategy in question 4. On an actual basketball court, the bench area is typically 9 meters long. Without measuring, determine how long the bench area should be on the scale drawing. Well, let's think this through. We know that the bench area is typically 9 meters long. So we're going to be multiplying some number, and that's a number of centimeters, times 2, and that will tell us 9 meters. Now, the reason this is true is because for every centimeter on the picture, it represents 9 meters in real life. And so if we know that the bench area is 9 meters in real life, we need to figure out how many it will be on the drawing by determining what number we multiply times 2 to get 9. So at this point, you should have answered 4A. You should have found out what this question mark is. I'm going to leave you to do that one on your own. We're not going to go over it. And we're going to skip question B. So if you haven't answered 1, 2, 3, and 4A, pause this video and keep working. Otherwise, keep listening and following along. If you missed class today, you are welcome to skip activity 7.3. You can skip 7.3. I'll write it here. Skip 7.3. And the last page is just a summary. Scale drawings are two-dimensional representations of actual objects or places. Floor plans and maps are some examples of scale drawings. Remember at the beginning of class when I asked you to predict what might be true about a scale drawing? Well, we know that every part corresponds to something in the actual objects. We know that lengths on the drawing are enlarged or reduced by the same factor. And a scale tells us how the actual measurements, so the measurements in real life, are represented. So for example, if a map has a scale of 1 inch to 5 miles, then a half-inch line segment on that map would represent an actual distance of 2.5 miles. Notice how these two parts, every part corresponds to something, and lengths are enlarged or reduced by the same factor. Those are the exact same characteristics of a scale copy. The only difference is that a scale drawing represents actual objects or places. Okay, so if you're still with me, you have 2 more things to do before you're done with math today. The first thing is back in the Monday folder. Back in the Monday folder, you have an assignment called 1.7 exit ticket. 1.7 exit ticket is worth 1 point. You can open up today's folder and just go ahead and do 1.7 exit ticket. When you're finished, you need to log into Khan Academy. You have 3 assignments posted in Khan Academy. The one you need to focus on is one-step multiplication and division equations. So again, focus on one-step multiplication and division equations. This will be the assignment that's homework for tonight. There are 2 other assignments in there that I'll ask you to work on later in the week. So if you want to get ahead of them, by all means, do a little bit of extra. As always, if you have any questions, please send me an email.